Continue with chapter 9, application of trigonometry. Question number 15. Here we have, there is a tree. Then the angle of elevation from a point A is 60. Then we walk 20 meter from the base to a point B. The angle of elevation change to 30. Then we have to find the height of the tree. So you see, we have the tree. Then at one point A, away from the top of the tree, we look up. The angle is 60 degree. Then they say we walk away from the base. So that means this is the base of a tree. So we are moving this side, okay? Far away from the tree. We move at a distance of 20 meter away. Then there we have another point B. Then when we look up to the tree again, we find that to the same place, okay? We find that the angle here is 30 degree. So we have to find the height of a tree. So again here, this one is the base, this one is perpendicular. So in order to find height of a tree, again we have to use tan theta, okay? So after drawing it nicely here, then we will see. Let's use in right triangle DCA. Here we have to use tan 60. Then we know that tan is equal to perpendicular by base. That means DC by CA. Okay. Then tan. Okay, we can use any triangle first. Let's take the big one first. Okay. DCB. Here if you take DCB, then it will be tan 30. So if tan 30 degree, again it will be DC by BC. So those. Then those we have. Okay. Then DC we don't know. From the table we know tan 31 by root 3. BC we don't know. But if you look at the figure, we can break it into CA plus AB. Those. So we cross multiply this one. Then because AB we already know, it plus, we take that side, become minus. AB we have 20. We cannot do anything, leave it there. We use the second triangle. Here 60, it will be DC by CA. Those. So here also we don't know both, but tan 60 we know root 3. So we cross multiply, DC we get it, CA root 3. Then here we have the value of DC, no, we get it from here, AC root 3. So whatever value we get here, we can replace it in equation 1. So instead of DC, we can write as AC root 3 here. Now from here we have AC equal to DC root 3 minus 20. So either you replace this one there, or replace this one here. Okay, same. So since we already write it as equation 1, let's replace this one here. So there we have AC, here also we have AC. So in place of this AC, we can replace with this one. Okay, so there, this one, remember, we get from equation 1. Then this root 3 is from here only. So root 3 into root 3 will be 3 DC. 20 into root 3 will be 20 root 3. We know the value of root 3, 1.73. So DC and DC, we can bring one side. This is minus, take that side, become plus. 3 minus 1 will be 2. 20 into 1.73. This is into, we take that side, become divide. So 20 divided by 2 will be 10. 10 into 1.73, we will get 17.3. Then DC, so it is DC only one, the height of the tree. That is equal to 17.3. Then next question number 16. We have a building whose height is 15 meter high. Then we have another factor here, that is a tower. So we have a building, we have a tower. Then what happened? The height of building is 15 meter. So we stand from the height of this building here. The angle of elevation of the top of the tower is found to be 30 meter. So from the building, we look up to the tower. Then we find the angle of elevation. So when it is angle of elevation, we have to get the horizontal. So we draw it that way. The angle of elevation there is found to be 30 degree. Then they say from the bottom of same building. So we come down to the bottom here. Okay. Then what did we do? The angle of elevation of the top of the tower is found to be 60. So from the bottom of the building, we look up again to the top of the tower. So here now, we have to refer to the horizontal crown. The angle is 60 degree. Then what we have to find? We have to find the height of the tower, this one, and the distance between the tower and building, this one. That means, again, we have this is base is perpendicular, so we can use tan. But here clearly you see it is a rectangle. So for this part, this is 15, this also will be 15. Then this one, it will be same as this. Okay, because this portion here is a rectangle. So I hope you understand the question. We have a tower, and opposite to the tower, we have a building. So if you stand at the top of the building, you look up to the tower, the angle of elevation. So that is why to get the angle, we have to draw the horizontal plane. It is 30 degree. Then if you look from the bottom again, okay, of that same building, you look up to the tower. The angle now is 60 degree. So let us find the value properly. So we can draw the shape properly there. We can write the given, okay. Then we want to find the height of tower. So we take AC height of the tower. The distance between building and tower, we take it as DC. So we don't know the value, so we can take any one first. So it's better, let us take this one first, okay. Right triangle ABE. So we want perpendicular and base, so again we use tan 30. Then tan 30, we know from here definition is perpendicular by base. So AB by BE. Tan 30 from the table, we know 1 by root 3. Then as I told you, that means this is a rectangle. So DC and BE will be equal. They are the opposite side of a rectangle. So in place of EB, we can replace with DC. Then there we cross multiply. We get DC equal AB root 3. So we cannot do anything there now. So we name it equation 1. Let's take the second triangle. 60, tan 60 in this big triangle. So it will be AC by DC. Then AC, we can break it as AB plus BC. BC we already have from here equal to 15. So the main problem now is to find AB. Okay, so tan 60 from the table we know it is root 3. Then DC we have from here AB root 3. We can replace with that. So AB root 3 we cross multiply. Root 3 into root 3, 3. It will be 3AB. Then after breaking AC, AB and AB we can bring one side. BC we already know 15. So 3 minus 1, 2AB. AB will be 15 divided by 2, 7.5. So we want to find the height of tower. It will be AC equal AB plus BC. AB we get from here 7.5. BC already given 15. 15 has no decimal. We plus with 7. So the height of tower is 22.5 meter. So remember, we also want the distance between the tower. We know it is DC. Then from equation 1 we have DC equal AB root 3. Since we know AB, we can replace the value of root 3. We know 1.73. Or multiply it, we get. So that means the height of tower is 22.5 and the distance between the tower and the building is 10.975 meter.